So we're going to talk about exponent properties. This is assignment 4 for the first unit. And first step, or first exercise, we're going to look at some of the properties for real numbers we talked about. And then we're going to get into some of the ideas behind what makes exponents and monomials, how the exponents change and when they don't change. So that's one of the things that people kind of goof up from time to time. So for like these first few steps, it just kind of goes through the reorganizing of what's taking place. They give us a pretty straightforward, simple question. The answer that you get is down the bottom, but they're going through the steps. Now you're not going to have to do this with every question, but just knowing the process is important. So in the cases of 1, 2, and 3, first thing we have is we have a reorganization of the parentheses. So for this one, that would be associative. Using the associative property, reorganize those parentheses. And then in 2, they take what's in the parentheses and they change the order. So because we're changing order around, that's commutative. And then for the third one, we're going ahead and again reorganizing those parentheses. So we're going to have the associative property again. And then you multiply them together and get the answer. So kind of thinking about exercise number 2. We're not going to do all of these examples. We're going to focus on a select few. So just do the ones that I do on the paper. If you want to try the other ones, that's fine. But like I said, we're gonna focus on just a few of them. We're not going to do all of them. So in the case of A, when we're talking about multiplying monomials, we have to multiply the numbers. You got 5 times 3, which is 15, and then x squared and x to the 6, which you add the exponents for this case. So you have 15x to the 8. Now here's the thing, a lot of people get confused with this. So here's the easy way to remember when exponents change. If you take something like 40 plus 20, okay, just a basic arithmetic question. Probably most of you know that's going to be 60. Okay. So what that means is that if I'm adding, let's say 4x and 2x, that means that I have 6 with 1x. The amount of zeros reflects the amount of x's. So if you do 40 times 20, you're going to end up with 8 and then 2 zeros. So we multiplied, that changed the amount of zeros. So when we're looking at questions like the ones we're talking about today, like A, you have to change the exponent because that represents a place value. Now with B, you know, if you don't see an exponent, it's a 1. -2, -6 would be 12, and then you have x to the 5th. And with something like D, when you see an exponent and another exponent raised to it, that means you are duplicating what you have based on that outer exponent. So you would have 4x to the 3rd and 4x to the 3rd, and you're multiplying those together. For exercise 3, we're just going to look at one of those ones. I'm going to look at B. Same thing like we talked about, multiply numbers, you get 8. And then you have 2 different variables. You're only adding together exponents for the same variable, so this would be x to the 9th, and then y, and you have 3 and 6, which would be 9. So just kind of be careful with those types of questions. So I'm going to erase this, and then we're going to go to the back of this page. Now I'm on the back of the page. You'll notice that exercise 4 is kind of working backwards. I want you to fill in the missing blank to get the answer. So realistically, what you would do is, if you were to divide both sides, kind of think of this as like our missing value. I mean, you can play a little guess and check if you want, or you can divide by both sides. But in this case, I know that 6 divided by 2 is going to be 3, and then x to the 5th divided by x squared would be x to the 3rd. So this should be 3x to the 3rd. If you can't see it, because it's kind of sloppy in there, but 3x to the 3rd will be in that blank, because 3 times 2 is 6, and x to the 3rd times x to the 2nd is x to the 5th. Okay, so that kind of gets the gist for these ones. Going on to exercise 5, we're talking about the distributive property, which we talked about in the first assignment. Same thing, remember we were multiplying, so if I take something like c, and I'm multiplying this out, I got negative 7x squared and then x squared, which would be a 1x squared. So I'd have negative 7x to the fourth. I have to keep my terms separate. Negative 7x squared times negative 2x. So negative 7 times negative 2 is positive 14. X squared, x to the first would be x to the third. Negative 7 times 3 is negative 21. And then only the x squared is there, so that's going to stay. And that's similar, like we just talked about, with questions like D and E. So like if we talk about D, it's y squared times x squared. So that'll be x to the third y squared as one term. Keep your terms together. And then we have x and y to the fourth, because there's one x, and then you have two y's, and then two y's that you're multiplying it by. So just be careful with questions like this, especially with ones with more than one variable. You want to make sure that you do them in the correct order and only combine and add the exponents when you're multiplying for the same variable. And then going on to the last one, it's kind of similar to 4. They're having us do basically what we did for 4, except now it's kind of factoring that distributive property. So they kind of give you the initial factor, which in this case is 4x, and they're asking you, hey, what could you multiply 4x by to get 8x squared? And what could you multiply 4x by to get negative 12x? So for like this first one here, well, I know 4 times 2 is 8, and then x times x will give me x squared. And then for the second one, 4 times some number gives me negative 12. Well, that's going to be negative 3. And there's x in the beginning, x in the end, so I don't need to put an x with that negative 3. Let's look at one other one. Let's look at b, the last one we're going to look at on this video. So you want to do the same thing. Again, you're going from 7x squared to 7x to the fourth. The number's the same, so you'd have x squared times another x squared. Then we have to go from 7 to negative 21. So that would be 7 times negative 3. And then going from x squared to x to the third would be x. And then 7 times negative 4. Sorry, my smartboard keeps throwing little symbols or curved lines on there. But negative 4 times 7 gives you negative 28. And then the x squared is the same, so there's no x that's going to go with that. So just be careful with questions like this on the assignment. We're trying to figure out that missing piece. You can use division. You could take that problem, and if you divided it by the number that was being distributed, what you would see is that the answers you get would match what I have in that parentheses. So there's another strategy for that. Okay. So as far as the assignment goes, okay, when you're working on the questions for this, it's pretty straightforward. Pretty much all the questions you're going to work on that are here, I'm not going to have you work on right now 5E and 5F, so you can cross those out currently for this assignment. All right, so good luck as you're working on it. And if you're in class and need help, of course, raise your hand and ask for help.